Okay, in this section, we're going to utilize our trig to just solve some geometry-like problems. To begin with, we're going to do problems where we just solve basic right triangles, and that is if you're given information about a triangle, being able to find the other things. So, for example, you first off know that this is A, B, and C. And the nice thing about trigonometry is now all we need to know is an angle and a side, and we can find out the other sides. Or if we know multiple sides, then we can find out all of the angles. So for example, if I've got a problem where I know that A is 5 and the measure of angle B, let's say, is 28 degrees, then I can solve the triangle, which means find everything else. Right now I know just that A equals 5 and B equals 28 degrees. So if I want to find out what little b is, for example, I could say the tangent of 28 degrees is equal to little b over 5, right? Because tangent is opposite over adjacent. Remember, this is where you might want to think about SOHCAHTOA in solving these problems. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that means that b just turns out to be 5 times tangent of 28, which equals, and on all of these, it looks like you're going to round to the nearest tenth when doing them. And so 5 times tangent of 28, and you're going to get, that would give you 2.66 is the answer for B. And then you got to go through and find C. And so to find C, well, again, if you know B is 28, C is the hypotenuse, A, which you know is the adjacent, so you would say cosine of 28 equals A over, or actually 5 over C, right? Adjacent over hypotenuse. Cosine is adjacent over hypotenuse, and so that would give you C times cosine 28 equals 5, because I multiply both sides by C, and so C just turns out to equal 5 over cosine 28, and so 5 divided by cosine 28 equals 5.66. So now we found out what B is, we found out what C is. They make sense since A equals 5. It makes sense this one's smaller since the 28-degree angle is smaller, and then it makes sense that C is bigger than A because C is the hypotenuse. You also know what the other angle is if you're asked for that. This is 62. That's just going to be 180 minus 90 minus 28. We'll give you that is 62. The other type of problem you can have is one like this, where you're given 2 of the sides. And so you might be given that this is 5 and this is 8. And then you're asked to find the rest of things. So if you wanted to find out this side, well, you're not going to want to use trig for that, because anytime you're given 2 sides of a triangle, you should use Pythagorean Theorem. So 5 squared plus a squared equals 8 squared. So a squared equals 64 minus 25, which is 39. So you take the square root, and a equals the square root of 39. And so 6.24 when you round. I think I said round the nearest tenth, didn't I? So it would be 6.3, 6.2. The one above would have been 5.7 when you rounded there. And then you go find the other angle. And to find the angle, it doesn't matter which one you choose. You can choose either A or B to go with. If you chose A, then you would say the cosine of A equals 5 over 8. And so A is just going to equal the inverse cosine of 5/8. And so you take the inverse cosine of 5/8, and you get A equals 51.3 degrees. And so B, either you could go and say that the sine of B equals also 5/8, and do the inverse sine of that. And so you would say the second sine inverse of 5/8, that's going to give you 38.7. You could have also just subtracted 90 minus 51.3 to find out what that angle is. There's some other geometry things that are going to show up. Some of the common ones on these is if you ever run into a problem where you have an isosceles triangle, so something like this, a triangle that has got the side lengths of 10, 10, 8. The way that we can find out the angles of this triangle is by recognizing that in an isosceles triangle, to the base, to the non-equal side, right? Two of the sides are the same, one is different. You can draw a right triangle in, and that right triangle cuts that side in half, and so this just turns out to be 4. And so we can find out what angle B is here by doing the cosine of B equals 4 over 10, and then taking the inverse cosine of that. So the inverse cosine of 4/10 gives you B is 66.4 degrees. So this is 66.4. Well, the reason that's good for us is because if that's 66.4, this is also 66.4 because it's an isosceles triangle. And so then you just subtract those two from 180, and you get that the angle C up here, the top angle, is equal to 47.2 degrees. Another common one is the area of a regular polygon. And to find the area of a regular polygon, so like, for example, a regular pentagon, what you do is you realize that all of these triangles are going to be the same, and they're all going to be isosceles triangles. All of these turn out to be the exact same, and they're all going to be isosceles triangles. And so you can find the area of that by finding the area of one of these triangles. And so, for example, if I find that height, so let's say, for example, let's say this is 10, and then you want to find the area of the polygon. Well, you find the height, which is also has a name in a regular polygon. It's called an apothem. And then you multiply it times the base, and then times 1/2. That'll give you one of those triangles, and then you just multiply it by 5. Now, you do need to know how to find this angle, which is the angle in a regular polygon. That is found using this formula. So you probably want to make sure you know this formula, and it's going to be 180 times n minus 2 divided by n. Okay, the 180 times n minus 2 is the sum of all the angles in the polygon. You divide by n because that's how many angles there are. So that's just going to give you 540 over 3, which is 540 over 5 in this case, which is 108. So this whole angle is 108, so half of it is just going to be 54. So what I end up with is this triangle that looks like this, where this is 54, and this is 10, and so when I drop this in, the side length, that just becomes half the side length. And so the height here, or the apothem, as I called it, so I'm going to call it A, is going to be the tangent of 54 equals A over 5. So A equals 5 times tangent of 54. And so you go ahead and multiply 5 times tangent of 54. That equals 6.88109. Be careful in rounding. Don't round until the very end on these kind of problems. So remember, that's the height. And so the area of this triangle is just going to be 1/2 times the base times the height. And then remember, we're multiplying each of these triangles. There are 5 of them, so we're going to multiply that by 5. So it's going to be 5 times my answer times 5 again, right? 5 from here, 5 from here. So the area of this polygon is 172.05 or 172.0. Pentagon with side length 10 is going to have that area.